Now, in a previous example, I took a look at the integral from 0 to 1 of 0 to 1 minus x and 0 to 1 minus x squared of xy z dz dy dx. And when I did all that, I ended up with 47 over 3360. But what does this mean? I said it was the volume of a solid. The volume of what solid? If we take a look at this thing here very quickly, what I integrated over was this region. Let's see, let's go from 1. It's kind of a sliver like this. It was a sliver region sort of a thing here. But this is not the volume of this solid. This is what we integrated over. So this is actually the volume of a solid in hyperspace. This is a hypervolume. Now, try to wrap your mind around this for a minute. In Calc 1, we took a look at the area under the curve over some region from A to B. So we found the area that was specifically under this curve. And then we went on to look for solids. So now we're working on with x, y, and z. So we have some surface that perhaps looks exactly like this. And we integrated over this region down here to find this solid. So when we went from an interval to cover an area to an area to cover a solid, now, oops, x, z, the next step up is a solid to cover or to be under, so to speak, this volume, this surface in hyperspace. So I'm moving up one dimension each time. It's a little difficult to wrap your mind around this idea because you can't visualize it. We live in 3 space. Well, actually 4-dimensional space if you think of time as being one of the dimensions that we live in. So to have objects beyond that in 5, 6, 7, 8 space, the mathematics makes a lot of sense, but trying to visualize it can be a trip. See, if I were to actually find the volume of this solid, it would not be 47 over 3360. In fact, one of the interpretations for a triple integral is if I integrate over E of 1 dz dy dx, this is letting f of x, y, z equals 1. This results in a volume. So if I were to integrate from 0 to 1, 0 to 1 minus x, 0 to 1 minus x squared of 1 dx, dz dy dx, here f of x, y, z simply equals 1, this would give me 5/12, which is the volume of this particular solid. But this 43 over 3360 is a volume, is a hypervolume. It's something in hyperspace. So the idea of simply interpreting this number as a volume really lacks meaning. It's a hypervolume. So, but there's a lot of uses for triple integrals, and one of the uses is right here. If I do a triple integral and let my function equal 1, that will give me the volume of this solid in 3 space. Triple integrals are also commonly used to find moments and center of mass. It's a physics application. Also in physics, we can use it to find the charge on a solid object occupying a region, it's supposed to be an E, a region E with a given density. It's another physics application. And we can also use them, or quite often do use them, for statistical probabilities. Statistical probabilities of distributions with 3 random variables. Okay, that was pretty ugly. So, and the fourth one there, like I said, we can use it to find probabilities, which we don't necessarily think of as having a geometric representation. So there are a lot of uses for triplet integrals, and even integrals, 4 and 5 integrals, depending on what you're dealing with. But it's very difficult to imagine it or to picture an actual surface or a solid that we're working with, because it's difficult for us to see beyond or vision beyond the 3 dimensions that you actually live in.